Hi everyone, so this is 2.4, solving equations with variables on both sides, which you should have done before, so it should be a little bit of a review, but let's go ahead and look at these problems. So when you have an equation with variables on both sides, you want to get the variables together. So the first thing I'm going to do on this first problem is I'm going to move over the 2x. And it doesn't really matter which way you go, as long as, oops, didn't mean to do that, as long as you get the variables together. So we have 3x plus 2 equals 14. And then now you can solve it like a regular problem, which I'm going to do over here. I'm going to subtract 2, just like a regular two-step equation. So 3x equals 12, divide by 3, and x equals 4. Now if you look at the next one, which is an equation that also has variables on both sides, but it throws in grouping symbols. So before we can actually solve the problem, we have to distribute. So remember that you distribute the number on the outside to everything on the inside. So this gives us 10x minus 2 equals 3x plus 33. And then again, we want to get the variables together. So I'm going to move over the 3x. This will cancel out the 3x here. And I'm left with 7x minus 2 equals 33. And we solve it like a regular problem. So x equals 5. Okay, now if you look at the bottom questions, these are a little bit different because even though we have variables on both sides, we're going to end up with some special answers. So on the first one, if I distribute, I end up with 10x plus 12 equals 10x plus 12. Since they're exactly the same on both sides, because if I were to keep going and subtract the 10x, I would end up canceling both the variables. So whenever I cancel both variables, I end up with either an identity or a no solution. And the way that you know the difference is if they're equal, like these are equal, then it's an identity. But if you look at this one, when I combine like terms here, I get 9m plus 5. And I subtract the 9m over, so both my 9m's are going to cancel. And I'm left with negative 4 equals 5. Negative 4 does not equal 5. So therefore this one is a no solution. But this one, where they did equal, is an identity. That means any number you plug into x will work in that problem. Okay, so when you have a word problem with variables on both sides, the first thing you want to do is make a let statement. The let statement is what you're looking for. So let's read the problem. It takes a graphic designer an hour and a half to make one page of a website. Using new software, the designer could complete each page in an hour and a quarter, but it takes 8 hours to learn the software. How many web pages would the designer have to make in order to save time using the new software? Well, the first thing I need to do is decide what I'm looking for, and usually that's in my question. So since it says how many web pages would he have to make, then my let statement, my variable, is going to stand for the number of web pages. So we're going to let x equal, or stand for, the number of web pages. So let's see, it takes him an hour and a half to make one page of a website right now. So for every page, it takes him 1.5 hours. If he were to get the new software, it would take him 1.25 hours per page, but he has to include those 8 hours that it's going to take to learn the software. So since we're looking to see at what point it's going to be more beneficial to get the new software, we're going to put both of these equal to each other, and we're going to see at what point will it be equal. How many web pages will the amount of time that he puts in be equal? So if I subtract 1.25, x, to get the variables together, I end up with 0.25x equals 8. I'm going to change that to a fraction to make it a little easier. 1/4 x equals 8. Because that way all I have to do to solve it is multiply by 4. So he would have to create 32 pages in order for the time it'll take him to make the pages to be equal, which means in order for him to save time with the new software, he would have to create 33 pages, more than what it would take for him to be equal. Okay, go ahead and try these problems. Take a second, pause the screencast, do the problems on your own, and then I will solve it out so that you can see the answers. Make sure you pause, because if you don't pause, the answers are going to pop up right away. Okay, so go ahead and check your answers. If you need to take time to look at it, then pause.